Welcome to DP Tutorials by Don Jarva. Now we will be interacting on one topic from electrostatics, which is electric field intensity due to an electric dipole at the equatorial point. We have learned that an electric dipole is a system of equal and unlike charge separated by a finite distance between them. Now, when let at point A minus charge be placed and let at point B a plus charge will be placed. Okay, due to this, that means there will be electric field intensity. Now, let that point P be at a distance x from the center O of the dipole, where we have to find the electric field intensity. So we have learned previously that for a minus charge, okay, for a minus charge, if I have these electric field lines, okay, if I draw these electric field lines, all the field lines will be directed towards the charge, or all the field lines will be acting inwards. Okay? All the field lines will be acting inwards. So over here, you have to represent that vectorially. Let me use this for this minus charge at point P will be directed radially inwards. So we'll take, let us at point P, that means we'll take this green vector, and this green vector is acting towards the point A, that means in the direction of P to A. With respect to point P, the electric field E1 is in the direction of 1, is in the direction of PA. So we will write over here E1. Okay, that is your electric field vector with respect to minus charge. Then, with respect to the plus charge, what will happen with respect to the plus charge? With respect to the positive charge, we already know that the electric field lines will be acting in the outwards direction. Say, with respect to this plus charge, if I take any plus charge, and if I draw the field lines, okay, if I draw the field lines, all the field lines will be emanating, or it will be moving outside of the charge. So in this case, the electric field lines, in case of an positive charge, it will be directed radially outwards. So in this case also, you have to at point P, what will happen at point P? The electric field intensity due to this plus charge will be directed away from the charge. So you have to represent in vectorially by using another vector. So I will use this purple vector, and at point P I will place in such a way that this electric field will be pointing outwards or away from the charge. So let E2 be that electric field intensity at point P due to the plus charge. So I will write here, let this will be one. This will be electric field E2. Okay? E2 will be the electric field intensity. So these are the electric field lines. And moreover, okay, moreover, since we have learned about all these details in the previous lecture, then one important thing that you need to know is that with respect to point P, the charges Q and minus Q are inclined at a certain angle, at a certain angle. So let that angle be theta. Over here also let this angle will be theta. So this E1 and E2, it has to be resolved into its respective components. So now I will take this vector and I will place it over here, and I'll take another vector. Okay, I'll take another vector and I will place it at point P. Okay, at point P. At point P. Now you already know from school geometry that if this angle is theta, it is obvious, okay, that if this angle is theta, it is obvious that that angle is also theta. If this angle is theta, that angle over here is also theta. The reason is because this angle and this angle is a pair of alternate interior angles. This angle and this angle is also a pair of alternate interior angles. So if this is theta, it is obvious that this angle also will be 1. This angle will also be 1. That angle will also be theta. If this is theta, that means it is obvious that this angle will also be 1. Will also be theta. Now, look carefully on this angle. If this angle is theta, it is obvious that this angle is also what? Theta. What is the reason? The reason is because it is a pair of vertically opposite angles. So if this is theta, it is obvious that that is also theta. So you have to write over here that this is also equal to theta. Then from this point onwards, you have to resolve the components of E2 and also you have to resolve the components of E1. What are the components of E2 along this vertical direction? Okay. Again, let me repeat. What are the components of E2 along the vertical direction? What are the components of E2 along the horizontal direction? Similarly, what are the components of E1 along the vertical direction? What are the components of E1 along the horizontal direction? So in order to illustrate that and in order to analyze that, we have we will analyze in another section. Then over here, we know that this purple vector represents what? Electric field lines E2 of 1 of the plus charge and directed in this direction. And we want to find, okay, and it's also obvious that if this is angle is theta, it is also obvious that this angle will be theta. From this, if we complete this diagram, that means we get a right angle triangle, whereby this will be the base, this will be the hypotenuse, and this part will be this part will be perpendicular. Okay, so how will you find this base? How will you find this perpendicular? You have to use what? Trigonometry. So how will you use trigonometry? That means you have to find what are the functions which relates between finding unknowns of perpendicular and base using cos and sine. So cos is base by hypotenuse. So hypotenuse, how much? How much is the value of your hypotenuse? Hypotenuse is 1. Hypotenuse is E2. Okay? Sine of E2. So from here, of course, multiply this side. So you'll have h cos of theta. So I will just simply write as well as E2 cos of theta. Okay? E2 cos of theta. This is your base. So this component, which I have marked as question mark, this component will be what? This component will be E2 cos of 1. Cos of theta. And this is acting on this direction. Okay? That is acting on that direction. So if you look from this figure, that means this is E2 cos of theta. E2 cos of theta is acting on this direction. So we will write over here, how much is this value? This value will be E2 cos of theta, acting horizontally on that direction. Then we will determine this perpendicular component which acts on this direction, okay, which acts on that direction. So similarly, in order to find this perpendicular, you use sine. Sine is perpendicular by hypotenuse. So that perpendicular part, this unknown, this unknown quantity is 1. It is, what is the hypotenuse? Hypotenuse is E2. So you write E2 1, E2 sine of theta. So that is E2 sine of theta. So this component over here, this will be 1. That component will be E2 sine of theta. So if you try to complete this in a form of a rectangle, that means if this is E2 cos of theta, that upper part also will be the same or equal and opposite. So now I will use another vector. In order to establish that relationship. Okay? In order to establish that relationship, so I will take this vector and I will put it here. And when I put that vector, if this is E2 cos of theta, it is very obvious that this component also will be 1. This component will be E2 sine of theta. Where is the direction? The direction is in the upward direction. So similarly, if you look in the main figure, E2 cos of theta in this direction, E2 cos of theta in 1. If E2 cos of theta is in this direction, then this E2 sin of theta will be in the vertical direction. So from here, okay. So from here, we will take this vector and then we will write this vector as well. This vector will be E2 sin of theta acting on that direction, upward direction. So we have resolved the components of E2. We have resolved the components of E2. Similarly, we will resolve the components of E1 in the same method. Okay, in the same method. So we look from that figure. This green colored vector represents electric field lines of E1 due to minus charge. Then we will write over here. This is how much? This is your E1 vector. Okay, E1 electric field E1. Then it is obvious that if this is theta, that means this angle also will be how much? That angle also will be theta. So this part of, if we try to complete this figure, it will be a right angle triangle. That part of the triangle will be the base. This part will be one, will be your hypotenuse, and this part will be one, will be your perpendicular. So in the same manner, if you work out, that means this will give you 1. The base, always the base will be 1, will be E1, okay, cos of theta. So this is the base, so I will write over here 1, E1, okay, cos of theta. And where is the direction? The direction is in this direction. So when you have to write all those methods. See, E1 cos of theta acting on that direction. So with respect to E1, this base component E1 cos of theta is acting on which direction? Is acting on that direction. So from here, that means with respect to E1, that means that component will be, the horizontal component will be E1 cos of theta acting on the same direction. Okay, acting on the same direction. Very, very important. So see, both these components due to E2 on the same direction, due to E1 also on the same direction. So now you have to find the vertical component of E1. So how will you find the vertical component of E1? Use the same method as we have discussed in the previous section. So over here, this will be what? This will be E1 sin of theta. Okay, so I'll just write over here. This will be E1 sin of 1. E1 sin of theta. This idea of resolution of vectors is very, very important. So this is your perpendicular acting in this direction. So this will be 1. This will be E1 sin of theta. That is E1 sin of theta. See, if you try to complete this figure, that means if you try to complete this figure, it will give you what? It will resemble a rectangle. So if it resembles a rectangle, if this is E1 cos of theta, this portion also will be E1 cos of theta. If this is E1 sin of theta, then this portion also will be E1 sin of theta. So I will use this other vector, then placing this vector over here, that means if this is E1 sin of theta, it is obvious that this blue vector acting in the downward direction, this is also what? This is also E1 sin of theta. Okay, I'm using the properties of a rectangle. Okay, so from here, it is obvious that this lower part, see or not, this is E1 sin of theta acting in the downward direction. So with respect to point P, this is the vector electric field E1. So the vertical component, this is the vertical component. So it is acting with respect to point P, it is acting in the downward direction. So I will take this vector and I will put it there. Okay, I will put it there. So how much is the value? The value of this one, okay, the value of this one, it is E1, okay, sin of theta, okay, E1 sin of theta acting in the vertical downward direction. But when you look closely into this figure, this E2 sin of theta and this E1 sin of theta are oppositely directed. So when they are oppositely directed, it is evident that they will cancel each other's effect. So when they cancel each other's effect, there will be no electric field line along the vertical direction if you take point P on the equatorial ring. So the net field will be due to these components of cos, okay? Due to the components of cos. So there will be no field, no electric field line, no electric field intensity along the vertical direction. Why? Because these vectors are opposite in direction. So the net electric field will be purely due to the horizontal component. So now we will write the equations pertaining to electric field intensity due to minus charge and electric field intensity due to plus charge. So we will use, what will be the working formula? The working formula will be the formula due to a point charge, 1 by 4 pi epsilon naught. Then over here this will be Q, okay? There will be Q divided by distance square. What is the distance square of the point charge minus Q up to point P? It is EP whole thing square. Okay? It is EP whole thing square. Then if you try to solve, you have to know what is the value of this EP whole thing square. Okay? So when you work out the value of EP whole thing square, okay, when you work out the value of EP whole thing square, then from that figure, okay, from that figure it is more or less like this. We have the triangle, okay, we have this figure like this. This is the center O of the dipole, this is the equatorial point, and this is the point where that minus charge is located, okay, where that minus charge is located. It is obvious that this is A and this distance is 1x. So using Pythagoras theorem, that means this distance will be how much? This distance will be x squared plus a squared. It is very, very clear. You have to use Pythagoras theorem. Similarly, along this direction also, with respect to what? With respect to point B, this hypotenuse, this distance PB also will have the same value, x squared plus 1, x squared plus a squared. So likewise, in that using that idea, we will incorporate that over here. So we will incorporate that over there, and then we will write, okay, over here this will be how much? This will be 1 by 4 pi epsilon 1, okay, Q divided by root over x square plus a square to the power whole square. But this square and the root will cancel. You already know that this square and the root will get cancelled. Yeah, the square and the root will get cancelled. So you get what? What will be your next equation? Your next equation, that means this E2, okay, that E2 will be 1 by 4 pi epsilon naught. Then you'll have Q divided by x square plus 1 plus a square. So this will be equation 1. And mind you, where is the direction? The direction of this E1 from the figure, okay, from the figure it is clear, is along PA. Along what? Along PA. Very, very important. Okay. Next, next, we will write the equations for what? Electric field intensity due to the plus charge. So what will be the electric field intensity due to the plus charge? Okay, so from here implies that this will be equal to, so 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught. Then this will be Q. What is the distance? Okay, what is the distance? Distance square of the point of the plus charge, okay, of the plus charge will be BP square. So over here you have to write what? You have to write BP whole thing square. BP whole thing square. So if you solve, okay, you'll get back the same step. Okay, you get back the same idea, and over here this will be x square plus 1 plus a square with that root term, moving square. Then what happens? The square and the root will get neutralized. Okay, the square and the root will get neutralized. So it will give you the same result as equation number 1. E2, that means the final equation, this will give you 1 by 4 pi upside down, then q divided by x square plus a square. This will be marked as equation 2. Now, where is the direction of E2? The direction of E2 will be along BP produced. That is why represented by what? Represented by this purple vector. So it is along BP produced. So over here, you have to write along which direction? Along BP produce. Along BP produce. So now incorporating the other ideas, we have all explained why the net electric field is given by this equation, because the electric field, due to the vertical component, it will cancel each other's effect. The vertical component are actually the same in the opposite direction, but along the same line of action, so it will not contribute to the total field. So the net field, okay, so the net field will be due to what? Due to the horizontal component. So we will write over here, taking common, see the values, okay, the values of E1 and the values of E2. Values, equation 1 and equation 2, okay, equation 1 and equation 2 are the same. Okay, equation 1 and equation 2 are the same in the sense that E1 will have this value and E2 will have this value. All the right hand side will be the same. So which means that when you look from this equation, that means the both the terms are the same. So which means that it is 2 times, okay, 2 times that value of 1 by 4 pi, okay, epsilon naught q divided by x square plus 1 plus a square, and the common term, okay, and the common term will be what? Will be that cos of theta, okay, cos of theta. So you have to find what is this value of cos of theta. So the value of cos of theta, okay, the value of cos of theta can be determined from that triangle. Okay, if you consider from that triangle, let me check on that triangle, from this triangle EOP, okay, from that triangle EOP, how will you find cos of theta? That means you have to use your trigonometric ideas. That means over here cos of theta. So what is cos of theta in that case? Okay? What is cos of theta in that case? So again, cos of theta will be what? What is the base? AOP. What is the base? Base is AO. What is hypotenuse? Hypotenuse is AP. So this EO upon OP. Okay, EO upon AP. So over here we will write EO, okay, EO upon AP. EO upon AP. And what is this value? Okay? What is this value of the EO? EO is nothing but that value of A. Okay? See, if I use from this diagram, this EO will be how much? That EO will be equal to A, and that value of AP will be equal to how much? Will be equal to root over x square plus x square plus a square. Then over here, since there's a radical term, a radical factor, so I will use in terms of exponential, then I will write to the power 1 by 2. Okay, to the power 1 by 2. So using that value of cos, okay, using that value of cos, we will write here. This will be 2, this will be 1. 1 by 4 pi epsilon naught, this will be q divided by x square plus a square. And what is this value of cos? This value of cos will be a divided by x square plus a square to the power 1 by 2. Okay? The power 1 by 2. And then from here, this comes the very important crucial step, whereby you have to reduce into the expression, rewriting the above expression in terms of EDM, which is the short form of electric dipole moment. Okay? Electric dipole moment. So now look at first at in the numerator term, we have the factor of q dot twice a. Okay? Q into twice a. And in the denominator term, okay, this factor is common. This factor is common, and you'll have some expression in that form, 1 plus half. And if you solve this, that means the final result will be what? The final result will be 3 by 2. Okay, the final result will be 3 by 2. So simply over there, I'll just write the expression of 1, the expression of 3 by 2. Over here, this value, okay, that value will be equal, that power will be equal to how much? 3 by 2. So this will be 3 upon 2. Then we also know that the electric dipole moment P is the product of the charge and the dipole length. What is this? What is this? This is your electric. Okay, this is your electric dipole moment. Electric dipole moment. Then this equation finally reduced to a simple step, okay, to a simple step, which is equal to 1 by 4 pi epsilon naught. Then this will be P divided by x square plus a square to the power 3 by 2. Okay, to the power 3 by 2. So this is your electric field. But from here, you have to put another assumption, and that assumption is that if you consider for small dipole, okay, for preferably small dipoles, okay, for small dipole, what happens for small dipole? Okay, for small dipole, that means the dipole is very, very small. This is point A, this is point B, and this is that point O. And the observation point is over here, and that is x, and this is small e, which means from this figure, okay, from that figure, it is very, very obvious that for a small dipole, the observation distance x is very, very large in comparison to what? In comparison to the distance a. So which means that looking at this expression, let me mark this expression as equation number 3. That means that term, okay, the term x square, okay, the term x square plus a square is equivalent, okay, is equivalent to simply what? To simply x square. What is the reason? Under the reason that a square term, it can be what? It can be neglected. That a square term can be neglected. So if it can be neglected, which means that equation 3 reduces to E equal 1 by 4 pi epsilon naught. Then you'll have P divided by X P divided by X squared to the power 1 to the power 3 by 2. So from here, it is using simple mathematics, this 2 and this 2 can be cancelled. Okay. From here, this 2 and this 2 can be cancelled, 2 and 2 can be cancelled. So what do you get? You get the final expression of, therefore, electric field is given by this expression 1 by 4 pi epsilon naught P divided by 1. P divided by X cubed. This is the final expression for the electric field due to a dipole on the equatorial line. Okay. This is the expression. One important discussion from here is that we need to also know about the special case. This special case is used to ask in your examination time. So how will you understand about that part? So special case. So the special case from here is that we have learned previously that the electric field on the axial line is given by this expression, okay? 1 by 4 pi epsilon naught, and if you remember, it is given by this expression, okay? Twice P divided by 1, twice P divided by X cubed. Let EE be that electric field intensity along 1. What is this? Along the axial point. Okay? Axial point. And moreover, okay, for this equatorial point, if EP be the electric field intensity on the equatorial point, then we have this expression. Okay, then we have that expression. Twice P divided by 1. Twice P divided by X cubed. Now, if you look at this expression, say if we divide, okay, EP by EA, what do you get? Okay? If you divide EP by EA, you have to write that expression again, okay? 1 by 4 pi epsilon naught. Then this will be twice P divided by X cubed. Over here also, you have to write this expression 1 by 4 pi epsilon naught. Okay, 1 by 4 pi. Oh, sorry, there's one mistake. This is twice P. It is only P. It's only. Let me write in a proper way. I will take the ratio of EA by EP. So EA will be twice P upon X cubed, and EP will be P upon X cubed. So here, this will be P upon X cubed. Then all the things will get neutralized. So here some of the terms will be like this factor and this factor goes, this X cubed and this X cubed goes, this P and this P also goes. So what do you get? You get an equation which is only equal to the number, like we have 2 and like we have 1, which means that this ratio EP, okay, EP by EA is equal to how much? 2 divided by 1. Okay, 2 divided by 1. Or this EP is to EA. Oh, there's some mistake. Sorry. This is EA. Okay. So EA by EP. So which means then this EA by EP, EA by EP, EA by EP, or EA is to EP is 2 is to 1. This is one form. And another important case is that from here, if you cross multiply this EP this side, then you will get EA is 2 times of EP. Okay, EA is 2 times of EP, which means that The electric field intensity due to the axial point is very large than the electric field due to the equatorial point. So these are very important from examination point of view, and they will be asked either as multiple choice question or it might be numerical